I was muted in the beginning, I think. Okay, welcome everyone to the second webinar in this series of the CUTLER project. This webinar is about modeling decision-making in municipalities using business process models. And I will also tell you about further methods and tools for the introduction of big data applications in municipal administrations, which is also applicable to, well, introducing any new software application to administrations, basically. So this webinar is live streamed on Facebook, and the webinar is also being recorded and can be seen later on the CUTLER webpage. So please mute your microphones during the presentation and switch your cameras off if you don't want to be seen. And questions will be answered at the end of the webinar. You can write your questions in the chat, or you can raise your hand virtually and ask the question yourself at the end of this presentation. So before we dive into it, I would like to tell you what gets us out of bed in the morning, so to say. So currently, with regard to climate change, we are still on a emissions trajectory that, if you look at all the policies currently in place around the world, we are still on a trajectory that brings us to about a 3 degrees warmer world if all policies are being implemented, and that's a big if. So this is a catastrophic result, to be honest. This is a range of a warmer planet that we will not be able to handle this, and this is really catastrophic. So what we are doing as an organization, as EuroSoc Digital, is we help cities to make a transition towards a more sustainable and resilient paradigm. So sustainable means for us that cities have a low or almost zero emission footprint, a very low environmental footprint, and they are resilient, meaning they are resilient to external shocks, for example, environmental shocks due to climate change. So this transition is a massive endeavor for any city, and we want to help cities here. And we do this by helping them make use of the full potential of digitalization for the purpose of this transformation. We offer scenario planning methodologies to help cities plan for the future and transform their current state. We offer policy games to help organize stakeholder processes and dialogue processes and so on. And we also help cities to include citizens in this transition process towards a more sustainable paradigm. We also have some principles we try to follow, which is we always try to have a systemic and holistic view of a problem, basically. We try to visualize as much as possible. We try to be flexible and hands-on all the time, which basically means we try not to stick to written documents or something like this. So we try to tackle problems as they come and regarding the dynamic they have. And we always try to be co-creative, which means we try to include as much perspective as possible and to help cities develop common visions. So much for our approach. So the content of this webinar, what I will be doing is I will be telling you about first conceptual specifications exercise that you should be doing before using any big data application to enhance policymaking. So this will be about structuring your problem space, forming hypotheses, and thinking in variables and data, and all doing this by using the method of causal diagramming. The second thing would be I will tell you about modeling decision making in municipalities. So this is about who does what in a municipality, who decides what. This is about finding the right entry points for a big data application or any new application, basically, and to bridge the gap between new technologies that have to be introduced in administrations and the policy development routines. And we do this by using business process model and notation. Sorry there, could you mute your microphone, please? Wherever that was. Thanks. And the third thing I will tell you about is how to safeguard that any new software in administrations offers a real value to its users. So this is about user requirements, is about user experience, and is about facilitating the communication between users and the developers of any application using the methods of user stories, story mapping, and wireframing. What I won't be talking about is any technical details about programming and stuff like this. If you're interested in this, you can look it up at this link, or you can attend the other webinars, of course. So this basically, all the methods I will be telling you about will be more or less a beginner's level. So if you're already an expert on any of these methodologies and formats, that I probably won't tell you anything new, but I want to give an introduction to all these methods and why they are useful and how you can use them. Let me give you a quick overview again of the CUTLER project if you haven't seen anything like this before. So let me 1 second. So what happens in the project is the following. So in the project, we gather a lot of different data. It's from open data, statistical information, sensor readings in cities, up to user contributed content. And all this data is analyzed to assess the economic activity, the social consequences, and the environmental impact of any policy measure that is of some policy measures that are implemented in cities. And the idea is to give all these information to policymakers so they can use them in the decision-making process. So they use all this data to inform their decision-making process, to monitor their decisions, to evaluate their decisions, and so on. And all of this is being done in initially 4, now 5 pilot cases who go through this whole process here. So our task as EuroSoc Digital within the project is here. We try to make sure that all the applications that are developed and all the information that are being provided to the policymakers are being provided to them in the right form at the right moment in their decision-making process. So this is basically our task. So I won't go into details what exactly all the pilot cases are trying to do with the big data applications of the project. You can read this up on the website if you want. But I want to pick the city of Antwerp as an example here. So the city of Antwerp has a problem, a goal they want to reach, and measures they want to implement to reach that goal. So the problem is Antwerp is being confronted with increased pluvial flooding due to increased rainfall because of climate change. Now, pluvial flooding means this is flooding that's coming back from the sewer system because all the excess water from a lot of intensified rain events, the sewer system can take it anyway, it comes back to the surface and floods the city. So that's the problem of Antwerp, and the goal they have is they want to improve the water buffering and retention capacity of the city. And they want to do this by installing garden streets and building garden streets. So garden streets basically are green infrastructure that have the capacity to store excess water and release it later over time to reduce the pressure on the sewer system, and so to prevent or at least reduce flooding. So how to approach this? What you should do first. So first you have your problem is flooding. You know you have to develop policy measures to tackle this, and you want to use big data analytics to do this, to help you with this. So how to approach this? And what you do at the very beginning is get a clear overview of your problem space. So you have to structure your problem space. The questions here are, what are your relevant factors in relation to flooding? How are they connected? What are drivers of change? What might be the impact of any policy measure you can think of? And can you use data to help you with all of this? And a good method to do this is using causal diagrams or causal loop diagrams. So this is a method that comes from system thinking, and what they do is they basically give you a clear visual representation of any given system you want to look at. So they work like this. Causal loop diagrams, they contain nodes, which are basically the elements of your system, the elements of your problem area. They contain arrows, which are the connections between your elements and which indicate the direction of a causality. They contain a plurality, it's plus or minus, which indicate the form of the causalities. So here the idea is, if one variable goes up, does the other one goes up too, or is it that one goes up, the other goes down? And they also contain loops, which may be reinforcing or balancing. So this all becomes very clear with these examples. These are very classical examples from, explaining causal diagrams, basically. So here you can see it's rather easy. If you're hungry, then this triggers more food consumption. The more food you eat, the less hungry you are. So this would be a small causal loop diagram of this whole phenomenon, and this would be a balancing loop, because the more food you eat, this reduces your hunger, but the more hunger you have, the more food you eat. So this is balancing itself, this process. Another example would be here. This is an example of a reinforcing loop. The more money you have on the bank, the more interests you get, and the more interests you earn, the more money you have in the bank. So this would be a reinforcing loop that's driving itself up all the time. So this is a small causal loop diagram inspired by the Antwerp pilot case. Maybe we can go quickly through it. So you have future rainfall here, which means the more rain you have, the more flooding you have. So this will increase, which is indicated through a plus here. The more flooding you have, the more pressure you have to make a better water management. And this can lead to the building of garden streets. So garden streets, if they are built, they are able to reduce flooding. So this is another arrow here with a minus. So you see, this would be an example of a balancing loop. But of course, garden streets, they have more than one effect. They also have the effect that they increase the biodiversity in the city, because the more green you have in the city, the more insects and so on you have, which has positive impacts on its own, which I didn't draw here, but still. And also garden streets, they can reduce heat stress, because the more green you have in the city, the cooler it gets. So you can model all these impacts that garden streets might have. You can also connect it to, another area that's important for cities, which is traffic. So we have here an example for a reinforcing loop in a causal diagram again. You have infrastructure for cars, which is basically streets, of course. This makes an increase in car traffic. And the more car traffic you have, the more need for car infrastructure you have, which also, again, would increase the infrastructure for cars. So that would be a reinforcing loop with other effects, because the more car traffic you have, the more CO2 emissions you have. So it's a plus here. The more car traffic you have, the worse is your air quality. So the more room you provide in a city for green infrastructure like garden streets, the less room you have for infrastructure for cars. So this could be a measure, to kind of break this reinforcing loop here. And well, this is an example for me. I think causal loop diagram are a very simple but very powerful tool to give you a holistic view of your problem and, you know, show you what you can do. So causal diagrams can be rather huge. This is an example done by a person called Giant Wick, who did a causal diagram for all the measures that Paris at the moment is implementing and, you know, making the city of Paris more sustainable. So you see here a lot of loops. Some are reinforcing, some are balancing, and this creates really a complete overview of all the measures and the effects the measures might have in the city of Paris. So benefits of causal loop diagrams. What they really do is they enhance understanding because they give you a visual, three-dimensional view of your whole problem area. They're able to, you know, align the understanding of different people because everybody is forced to, you know, externalize its own mental models and explain to other people what he means by this node or by that element in the causal diagram. So it can trigger discussions about all the nodes and all the hypothesized connections between all the nodes and loops and so on. They can also reveal knowledge gaps because you can also see, well, okay, I'm not sure what exactly this causal connection might trigger or how this might work. So maybe you can see where you have to gain more knowledge and have to, you know, implement some studies before deciding anything. What they also can do is they can trigger system change because they can reveal leverage points for your policy measures. So, for example, as I said before, if you want to break this reinforcing loop here, which has, you know, bad environmental impacts on CO2 emissions, air quality, for example, what you could do, you could improve garden streets and give green more room and provide less room for car infrastructure. So this would be an example for a leverage point to break such a circle, for example. What they also can do is when you're in a, you know, when you want to use data to help you with all of this, causal diagrams can help you prevent hunting for unnecessary data. Because if you have structured your problem space well enough, you know exactly what data you should look for. You should can ask yourself, well, do I have rainfall data? Do I have data on flooding? How much flooding is it? Do I have data on biodiversity and so on? So causal loop diagram help you to prevent hunting for data that you actually do not need. And hunting for data is very, very time consuming and very hard. So every day you don't have to spend on hunting for data unnecessarily is a win, in my opinion. So this is two examples of tools you can use to create causal loop diagrams. One is called Kumo. This is the web address. And one is called Miro, but you basically can use, you know, any whiteboard in the internet to work remotely with people, or you can just simply use pencil and paper to draw causal diagramming. The second issue in this webinar is I wanted to talk about modeling decision making in public administrations. So, for example, in relation to flooding, the question would be who makes the decisions in relation to flooding and how? And the mission here would be to make decision-making procedures as clear and transparent and easily understandable as possible. So you can identify who can profit from a new tool, the CUTLER tool, for example, or any new software. Where are the correct entry points for a new software which should be introduced? And the challenge here is then to come from rather big decision-making procedures, which can take a lot of weeks or months or even years, for example, to come to smaller workflows of individual people sitting in front of a computer using any new software. So we approached it like this. Maybe you have very high level general task in an administration, which could be something like write a report. So somebody or a group of people is writing a report in administration. This report is circulating among other departments, and they try to continue the report and so on. So this is a rather high-level general task. So then we could ask, well, what does that mean? What specific tasks are there in connection to writing this report? And this could be something like, well, if you write a report about the problem of flooding in the city, then you would assess the economic damage in the city, and you would perform a spatial analysis in the area, flooding area, for example. And you could also still go deeper and ask, okay, what does this mean? Example. And for assessing the economic damage, you could check flood maps, and you could check mobility plans in the city, and so on. So this was our way to come from very general high-level tasks to really specific and detailed tasks that can be performed with the software and will add value to the overall task. So how did we do this? Sorry, guys, could you mute your microphone, please? And there's some microphone open. Thanks. Great. Okay. What we do to reach this goal is we model decision-making procedures in the public administrations, and we created business process models using a special form of notation, which is called business process model and notation. This is a globalized standard managed by the Object Management Group. It's also readable by software because you can transfer it into an XML code. And what this form of notation basically does is it can visualize workflows and can show you very concise what tasks are performed in a workflow, by whom, and in what order. So what process model basically consists of are tasks, sequence flows, and gateways. Process models consist of a lot more elements, but let's just keep these few elements, to get the idea across. So, and they also have a beginning and an end. So a very easy example for a workflow in BPMN 2.0 would be something like this. If you want to participate in this webinar, the starting point would be, well, you're interested in this webinar. Second task would be you register, then you open WebEx, you participate in the webinar, you close WebEx, and the endpoint would be, well, webinar attended. So this is a very simple example of this form of notation, and it shows you the whole process which would be necessary to attend this webinar. So you could add another task. Well, you could say, well, someone has to conduct the webinar. So you have another task that you could model in parallel to the participating task. So you would use two gateways here. These are called parallel gateways and allow to model parallelized tasks. So parallelized tasks are happening simultaneously at the same time. So next thing you could do is you could also model who is responsible for any given task in the process. So you use something we call lanes here. So in this lane would be you, all the participants of the webinar, which still have the same tasks to perform. And this would be me here because I'm conducting the webinar, right? So you have a clear overview of which tasks are necessary to perform a specific workflow, what is the correct order, and who's doing them. So I wanted to ask you to do a small exercise with me, if you like. I wanted to ask you if you could, well, if you want to, please try to model the workflow of withdrawing cash from an ATM machine using the following elements, which is basically try to bring them in the correct order, and maybe you can even try to use the symbols correctly. So we have here money needed, we have here money received, then we have a task that is called enter amount, a task that is called insert card, then we have two parallel gateways, then we have two more tasks without dispense money, charge bank account, and prepare the withdrawal. I would like to give you 30 seconds or something. Maybe you can come up with a solution. Okay, let's see who got it right. This would be an example of this process. This is the solution. So we have the beginning of the process as money is needed. The first task would be to insert the card. Second one would be to enter the amount. Then you have a parallel gateway because two tasks are in parallel, which is prepare the withdrawal, charge the bank account, and then issue the money. And then the endpoint would be money received in this case. So thanks for participating in case you had. So the great thing about this form of notation, business process model annotation, is you can use this to run in a business process engine. So a business process engine basically is a software that runs the process for you, which basically means it guarantees that you do the task in the correct order, and it also gives you the appropriate user interface you need to perform a task. So it would look something like this. If you would use this process in a process engine, the process engine could provide you with a user interface to register for the webinar. It could provide you with a button to open WebEx, then you participate, and then it will provide you with a button to close the WebEx application, and then the process would end. So to realize this, of course, you would have to do some technical adjustments to the engine and connect it to the applications you want to use, and maybe you have to create some user interfaces. But this is the general gist of how this would work. If you're interested in how this is being implemented technically, you can attend the webinar number 8. I think this will be a topic there. So the 8th webinar in this series of the CUTLER project. What also would be possible with a process engine is you could automate decisions. So, well, taking this example again, maybe before attending this webinar, you want to evaluate if you're really interested in this webinar or not. So you think you look the webinar up, you read the text, and then you decide if it's interesting for you or not. If it is interesting, then you register, open WebEx, participate, close WebEx, and so on. If it's not interesting, you just go for a walk and do something else. So normally, this evaluation task here is done by you manually, like internally in your head. You make the decision if you want to participate or not, but you could also let the process engine do this for you. And this would work like this. The precondition would be that you let the process engine know what your criteria are. So you would have to define something like this. If the webinar is longer than 2 hours, then evaluate as not interesting. If the webinar is on Wednesday, maybe every Wednesday you go for walks. So if the webinar is on Wednesday, evaluate as not interesting. If the webinar is on Wednesday, but it is shorter than 2 hours, then still evaluate it as not interesting. So you would have to define all this beforehand and let the process engine know. But then the process engine could automate decisions for you. Well, so of course, this makes only sense if you do a process over and over again. If you just make the decision once, then it wouldn't make any sense to use the process engine for this. But maybe there is a whole series of webinars with different lengths on different days on the week through the whole year. So it's a process that will be repeated over and over again. Then you could do something like this, and the process engine could, make the decision for you, so you wouldn't have to do it yourself. So this would be a form of automating decisions in a process. So the benefits of process modeling, again, they enhance understanding because they give a visual overview of a concise overview of the process and make it understandable to everyone. They align the different understandings which different people might have and about the process and the process participants. And again, it can trigger discussions about the process. It can reveal knowledge gaps. So you can ask, where is the process not sufficiently defined, for example, what tasks are missing, and so on. And it can enhance the process because you can always ask, well, maybe there is a more efficient version of a process to have a specific work being done. And you can also ask, well, what could be done by a software here? Like, for example, in this case, you could ask, well, maybe I can use software which allows me to register, open WebEx and close WebEx all in one application. Okay, so much about process modeling. The next issue on our list was safeguarding that software offers a real value to users. This is about new software, of course. If you want to introduce new software to software users in administration, for example, your mission should be to have to have a clear understanding of the needs of the software users beforehand, before you do any programming. So it's very crucial that those people who use the software communicate with those people who will build the software and vice versa. And a methodology to do this, to reach this goal, would be first to write user stories, to take the user stories and create story maps, and to take the story maps and create wireframes. I'll explain this in a bit. Let's start with user stories. So user stories are simple one-sentence descriptions of a software feature told from the perspective of the person who wants that feature. So there's a template for it. The template is always the same. It is, as some form of user, I want to do something so that I receive some form of benefit. It becomes much more clearer with an example. Let's say from my point of view, I can say, as a webinar instructor, I want to manage who registered to the webinar so that I can adjust to the participants. Or from your perspective as participants, as a participant of the webinar, I want to register first so my participation is guaranteed, for example. So the idea is here that software developers get an idea what features users want and why. So in this case, you already know, okay, there should be the possibility to register for the seminar, and you also know why people want to register for the webinar. And you have also two different viewpoints, because the viewpoint of the instructor, he wants to manage the registrations, and the participants just want to participate and want their seat to be saved, can be different. So we have also a first impression of what kind of user interface is necessary for the registration. But then comes another form of aspect to user stories, which are called acceptance criteria. So acceptance criteria, they deliver the necessary details to a software feature. So the user story gives you, okay, the idea why people want to register. And the acceptance criteria can describe, well, how exactly should this look like? And then you could say something like, well, I want the name to be there. I want the organization or the company of the people who register. And as an instructor, for example, I could say, well, I want the number of participants to be limited to 10 or something like this. So the idea is here that developers now know the software feature and they also know all the details that are necessary to have a complete feature, which in this case would be 3 entry fields, for example. And so they can, kind of check boxes, and they know when they have a complete feature developed. So the idea is developers know exactly what to do, and there will be no misunderstandings. So if you do something like this, the idea is to get as many potential users of your future application as possible and to generate as many user stories as possible about your application. This can easily amount to some 100 different user stories with acceptance criteria or even more. When we did this for the CUTLER project, we had about 100 distinct user stories plus acceptance criteria. And normally it's about that one user story more or less is one software feature approximately. So when you have all these user stories, the next step would be to create story maps. Story maps is about, bringing a logical order in all the several hundred user stories you have now. So user stories tell a story in an application, so to say. They give the right order. So you read user stories here from left to right. This indicates a sequence. First you do this with the software, then this, and this, and this. And it also matches subtasks to their parent tasks or subfeatures to their parent features. So we have a clear overview of the application with all the user stories. And in the end, this can be rather huge story maps. This is an example from CUTLER, what we did, and they are even longer because they continue to the right here. But you have a concise overview of all the software features that are wanted by users, and you have the right order and the right task-subtask relationship. Tools you can use for this are, again, Miro or Trello, but there are other different as well, which all work quite well. So again, the benefits of story mapping: you have a visual view of all software features and their connection to each other, which again greatly enhances understanding and avoids misunderstandings. Again, you can align your understanding with all the people who are working on the software and also the potential users of the software, so they have a shared understanding. And you can have discussions about features and about the flow of the features in the application. You can see where gaps are, so you can ask, okay, there are features missing, or there are features that are not good enough defined, and can tackle this problem. And the very good thing about this, you can make changes before any actual programming is being done. And this is, again, another, in my opinion, very powerful method to avoid small mistakes in the beginning that can amount to huge problems afterwards. So the next thing you could do if you have done this is start creating wireframes. So wireframes are just rough drawings of a user interface, again, before any actual programming is being done. So this is an example from Thessaloniki, from the CUTLER pilot of Thessaloniki. And this is a drawing of a user interface. So we know users want to have the possibility to select sensor stations. Sensor stations are here, and sensor stations are here in the dropdown. And they want to select air pollutants, which is possible here. And they want to select a time frame. And then they want to see bar charts or line charts with the results. And you can reach this with just doing a rough drawing and can show this to a program and say, okay, this is what the users need. Let's discuss about this. So you can see how an interface can or should look like from a user perspective before any actual programming is being done. So this is the same example from a snippet of the user story maps. So this is exactly the same information in this form, and this is exactly the same information as user stories formulated by users. And this was the actual end result, which looks a little different, of course, but all the features basically are there that the users wanted. So you have these sensor stations here, you have the pollutants here, you have your bar charts, line charts, and bar charts here. So tools you can use for do this, I got to know this tool later, because what I actually used for this is PowerPoint. You can do this, but it's not very good, to be honest, but you can use anything you like. But Balsamiq is very good because it provides you with a lot of functionalities and makes drawing user interfaces really, really easy. But you could also use just pencil and paper. You can use everything. Everything is okay, which gets the point across, basically. So what do all these methods have in common that I just showed you? All these methods are visual methods, which greatly enhances understanding. They help to align all the different subjective opinions of people, because it's very hard to talk about stuff, but it's very easy to just point to stuff that is, lies before you in a visual format. And this all triggers discussion, and you can easily make changes before you actually do any programming. So what this does is it saves a lot of money and work afterwards, because normally if you're writing documents, just huge software specification documents in the beginning, which cannot be changed, and then programmers go and implement everything that is being written in the document, then maybe they implement everything that has been written. But if there were small mistakes or misunderstandings in the beginning, this can amount to huge problems afterwards, which can, basically cost you a lot of money. So all these methods I just showed you are very good to avoiding this. Okay. Thank you very much. Thank you for attending. I'll be taking questions now if you have any. And if you're interested in further infos about the project that we'll be doing, we're happy if you attend all the other webinars, or you can have a lot of information under these links here. So thanks very much. Questions are welcome now. There do not seem to be questions yet, but maybe we just give it 1 or 2 more minutes. Okay. Sorry, there's one question, which is, can we present an example of BPM for CUTLER. Yeah, I can just. I have to look it up first. Just a second. Sorry. 1 second, please. Actually, I had these examples in the presentation, but I took them out. I thought they were too detailed, but I will get them back. Just 1 second, please. So I hope you can see again. So this is an example of the Antalya pilot case. This is the very first BPN we did for Antalya. So here are different, so we have different lanes here from different process participants in the process. We have the tasks here that are being performed. And this was very general workflow right in the beginning of the project, where we try to get an idea and then a first impression what has actually been happening. And this is an example of all the general, very high level general tasks I told you before. And here we have the general task, and then we identified that the actual interesting tasks where CUTLER could be applied would be happening here within these tasks at this lane below. Then we kind of zoomed into them and tried to get more information about these tasks, and then we revealed that there are still, more detailed workflows within these tasks, basically, which then looked something like this here, which is still contains a lot of tasks which are more of a mid-level abstraction. And then you can even zoom more into it, and for example in this case, and then you have an even more detailed workflow. And this would be now an example for a workflow that's on such a specific level that you could use a software here. It wouldn't be possible, or it wouldn't make any sense to do it here, because these are way too general, these tasks. But if you zoom in to the task on a specific mid-level, and then even further down to a more detailed, very concrete level, then you reach a level where you can use actual software to perform the tasks or with technology. Does this answer the question? I hope so. Well, the next question here is, maybe we can show how was this implemented? How was this implemented as dashboards? Where I can't show this because I don't have the necessary information to do this, or the necessary logins. But sure, that would be interesting. Yes. Or did I get the question wrong? I'm not sure. All right. Yeah, no problem. Okay, this was everything, I guess. So thank you for joining. Thank you for listening to this webinar. Please also please also consider attending the other webinars, which are quite interesting. And well, yeah, thank you again. Bye-bye.